Hi guys, so this is part 2 of the Hantek HCM 3065 or 3000 series actually that I've created software for it. In part 1 we just had a console application to test the low-level software, which is based on that National Instrument Visa layer, which was pulled in by a demo program that I downloaded from the Hantek website. So we're not exactly going through that again in this episode, and you can go back and watch it, the part 1, to get the information on that, which you will find if you go to my channel here. There is I've created a playlist, Hantek DMM, and there's the initial review that I did, sort of a very short review, and the beginnings of the writing for the software for it. So you will be able to view that over there. And what you see on the screen right now is the Visual Studio. I think it's 2022 or something, Community Edition, which you can download for free from Microsoft. The actual software I put on GitHub, as you can see over here, and I called it Hantek UI, and I think it actually comes up. I put it here as a pinned version. I guess it will show up there like that, and that's the code, and a couple of links here that will also be in the description as well, where I downloaded certain things from. In order for the software to work, you need to have this Keysight IO bundle drivers loaded and installed, and there's some documentation here on the Visa commands or methods that you can actually call, but you shouldn't really need to look at that unless you are wanting to extend this software a lot further. And there are some Hantek downloads here. You may not need those either, but there is the original demo program was there, which I based the original software on, but this software over here is completely rewritten. So in any case, it's there to have a look at. What you will see is that there is a little man over here which you can click on and it'll start running. It's hard to get the cursor on it sometimes. So there it is, it's going, and you can see on the screen over there it takes readings. Got it set to 3 readings a second, I think, and right now I've got it set for, there are settings. Let's go there. So right now I've got it set for to be a transparent window, which is the way I would normally use it in YouTube. I'll show you in a minute. You can actually turn a window border on, so it'll have it won't look like this. This is kind of like, looks like Windows 7, but it'll have the Windows 10 border, of course. You can change the colors of the actual values, the unit, which is the over there, and the mode, which is over there, and you can actually set the precision. Got it set to 3, let's set it to 4, and the timer interval right now is 250, so it's 4 times a second. You could speed it up or you could slow it down, 5 times a second, roughly 3 times a second. So you can say OK, and as you can see now, it is got 4 digits on the display, which is actually similar to what the multimeter is displaying, as you can see. So there's a little button over here that you can click, and you can actually change the mode. So we could go to AC voltage. So now we're reading, because the probes are just laying on the desk here, picking up noise, from the environment. So we got DC current, AC current, resistance 2-wire, resistance 4-wire, frequency, capacitance, continuity, and diode mode. We will check those things out, and let's go to resistance mode. So we just get overload because there's nothing connected to the probes. And let's stop it for now. You can also stop it over here. There it is, start stop. For some reason the little icons over here have to be right in the middle, or yeah, like that. You can see in the little blue circle the pointer is deceiving, and if you do exit, of course it shuts down. In any case, so I have I'm using OBS Studio to record right now. Let's turn off display capture. And I have created a setting in OBS Studio for it, which actually looks for the window that in Windows. So there it is. And I can actually move it around. And as you can see, it is actually transparent. So if I put it at the top over here, and I put on the other camera to look at my desk over here, so you can actually see that the that's not what I wanted to do. I wanted this one. So you can see I can move it around. I can put it elsewhere. I can actually that's the whole aim of the game here. I can actually make it larger or smaller, like so. But let's leave it like that for now. There. Okay. So here are the probes of the multimeter. I have an old, I think I used this in part 1 as well. Got an old Radio Shack Micronta CR box, substitution box. This thing is very old, and I got to open it up and clean the switches and so on. So some of the values in there are not going to reflect what it says on the dial, but nevertheless, we are in resistance mode. So I'm going to hook up the hooked up the probes here for the resistance, and now I will go to the thing over here and make it run. So there we go, now it is running. You can tell because the little red man that is running is red. Now the multimeter has a setting where you can actually turn the display off. And to be honest, normally that's what the mode that I would use. I would just turn the display off because there's no point in watching that display flash on and off like that if you got it on the screen. Okay, so what have we got? We are set to 10,000 ohms, so that's 10k ohms. This is 15 ohms. And as you can see, it is reflecting what it is, 5700 ohms. And now something peculiar happens on the multimeter. It actually goes to kilo ohms as soon as it's over 100 ohms. So it shows 0.130 kilo ohms, which is, I think, kind of undesirable. I don't know if it does the same thing when you don't have remote, but in any case, another reason to turn the display off, because as you can see, our software is actually displaying it in what I feel is a better way, 130.4482 ohms or whatever it is. And it's the same. This one's supposed to be 220, but it's actually coming up with 304 because the switch is probably corroded. 470 is actually a bit less. And now when we get to 1k ohm, as you can see, the value goes to properly to 1k ohm on our software. 1.5, 2. Supposed to be 2.2, but I think, as I said, there's a bad connection there. The important thing is that we are seeing the same thing that the multimeter is displaying, which is accurate. And now if we go to k ohms, we are now in mega ohm region. This is as high as this box goes, 10 mega ohms. That's supposed to be 1 mega ohm. Yeah. And again, it does the same thing as it did with k ohms. At 477 kilo ohms, it actually goes to mega ohm mode on the actual display on the multimeter. But I would rather see it as 478 or whatever it is kilo ohms. Okay, so that's, as you can see, that's working. So we can now go and you could select capacitance. There we go. Okay, so what have we got? It says 0.010. Let's make sure it's making a good connection here, because it's now capacitance is not a feature that is its strong point. It only goes up to 120 odd microfarads, but I think I've seen, but it's officially 100, I think. And it's almost like they put it on as an afterthought, and in actual fact, it's kind of interesting because they didn't even put a capacitance button on there, but it's actually, like you can see it over here, it is actually coming up above frequency over here. The blue, you have to hit the shift key to get to it, which is not quite convenient either. And it doesn't particularly worry me. The multimeter has been working very well. It's very accurate, and I can control it via Skippy, and that's important to me. But it's obviously meant to be a lab device, which together with other devices that can be put on the same network, like an oscilloscope and a function generator, and so on, that you can actually control. For there's like software called LabVIEW, which you can actually create scripts for, so you can actually set these things in different modes, record values, and do all sorts of stuff with that, which you would do if you're an engineer in a lab environment. So measuring capacitance is not something that you would really do in an environment like that. And besides, I have LCR meters, several of them, which is what I always use to measure capacitance. I don't use my multimeters for that because they tend to be less accurate, and also they're very slow. If you put a big capacitor on multimeters, some of my multimeters can actually measure right up to a millifarad, but it can take them quite a while to measure a large capacitor, whereas the LCR meter is almost immediate. In any case, this is 2 nanofarads, 5 nanofarads. Okay, and then the biggest that this has got is 220, and for some reason it goes to microfarads, but I want to see that as nanofarads if it's less than a microfarad. And to give you an indication what I'm talking about, I've got a few little capacitors here. This one here is 47 microfarads. It took a while for it to read it, even though it's just a small capacitor. That's what I mean with multimeters. You know, they read capacitance different than an LCR meter. They kind of measure the amount of charge that goes into the capacitor over time, and they calculate it from there. An LCR meter actually measures the capacitive reactance at a particular frequency, and then it's much quicker. So this is coming back with microfarads, so that's good. Now here I've got a capacitor that's actually marked to be 100 microfarads, but I think it's slightly more. But it displays, after a while, it displays 119 microfarads. And here I've got another one that says it's 100. And I don't think this one is more than 120, and it's just not able to deal with that. As you can see, the highest range it's got is 100 microfarad range. Yeah, can't read this one. So that's, I mean, the capacitance reading on this multimeter, and I presume the Keysight one would be the same, since this is what they cloned and copied. I'm not sure though, I haven't looked at the specs. So as you can see, it works quite well, and this is what I had in mind in order to be able to use it with YouTube videos and putting values on the screen. Of course, I have a choice. In the settings over here, I can actually tell it to use a window color. I'm choosing black right now. I can say OK, and as you can see now, it is like a black value there. I can adjust the window, of course, by size, or I can narrow it down if I know that the value is not going to be that large. So all's well. So I can actually turn off the camera on the device here. The only other thing to mention is I'm going to say stop it, and I'm going to say exit, and now I'm actually going to turn the multimeter off, so it is not actually making any more readings. And now you'll see the error handling. You see now there is a little icon over here which has error messages. Could not find the Hantek device, make sure it is on and connected to the USB port, and send command write to set it to capacitance mode, failed with message or write failure. So when there are errors, they will end up showing as a little red icon, and after you read them the icon goes away, but the Hantek device is not on, so it can't display anything, and that's the way it will look. Alright, so this is what we have created. It is on GitHub. There will be some more information in the description. There's some links and things, and you can look at that. If you are interested in how the actual software works, we're going to do a code review next. And but if not, the code review will take a little while. So if you're not interested in that, or you want to fast forward it, go ahead. But if you do stop watching the video now, that's fine, and I'll see you guys later then. And don't forget to like and subscribe and stuff like that, and I will then see you guys later, as I said. But we're now going into the second part of this video, which is the code review. Okay, so we're going to have to do a quick code review here. I did a previous code review and I recorded it and it was over an hour, so that's too long. We'll have to skim through it a little bit faster, and if there's any questions, just leave them in the comments on the channel, or there is a section on GitHub where you can ask questions as well. So this is a class view we got over here. We have at the top level we've got Hantek UI, which is of course where the forms are hanging out, and the settings. But at the lowest level there's Visa 32, which actually talks to, it's like an onion, it's like layers, and the inner part talks to the device via USB, and that's done over there. We're not going to look at that due to time constraints, but of course I already did a review on that as part of the code review of the test program in part 1, so you can look at it there and get more information on that if you want. And then we have the next layer up from that is actually Skippy, and the purpose of this set of classes that's under that namespace there is to actually talk to the device and to make the data that it has available to the top level program, the forms and so on. And it actually stores its information in a class called Skippy query value. The information that comes back from the multimeter from the device is stored in there, and there are some helper methods to actually view the information. So like for instance, if it is farads capacitance, it actually gives you the value in farads, so you have to actually convert it to show microfarads or picofarads or nanofarads. It is all done in there. Same with voltage, millivolts and so on. Then we have a convenient way to store the mode that the device is in, which is an enumeration, which is measure mode. And we've got an error list if there's any errors, and the error list has error items in them. We will have a quick look at all those things, but this is just explaining the hierarchy of things. So at the highest level then, the next level up from Skippy, is that we have forms, and also there is some code for settings in order to read and write those. So first thing we can actually have a look at is the measure mode. As I said, it's just a simple enumeration here. DC volt, AC volt, resistance, current, frequency, capacitors, diode. I've even put temperature in there, but we're not using that at this point. I don't have a temperature probe. Settings are over here. Whether we have a border, the precision, the window color, the mode, text color, unit color, mode color, font and interval are all stored in the settings, so that next time the program starts you will find that it'll start up exactly the same way that you left it the last time. That's the purpose of that. The forms themselves, of course, are defined by these design mode windows. This is the actual front-end screen design, and there is a window for a form for the settings as well. Then we have the actual well, we can actually have a look at the this is the error list and the error item. They're in one file here. It actually stores an error ID and a description, and the actual errors come from the device formatted like this, either a plus or a minus, up to 3-digit number, and then there is whatever the error or warning is in a string with quotes around it, and this code over here actually parses it and then puts it in this error item. And the error item is actually stored in a list of error items. That's what that's all about. And then the next level up is well, we might as well look at the Skippy query value over here. This is, as I said, this is where the value that comes from the device is actually stored, but it also formats it for output. Hence there is a format mask there, which actually at runtime gets modified depending on the precision. And you can see that happening here. The precision, if it's not specified, it goes to 5 by default, and it actually creates a format mask with this method over here. Creates a format mask for it, so that the output will be formatted the way we want it. It stores the query value, stores the actual current mode, and it actually is able to output a measured description. That's still coming up. Like for instance, if it's DCV, we want to see voltage DC, you know, on the window, and that's what that does. The value is actually stored here as a string because it comes in as a string from the device, and something a method here in order to turn that string into a numeric value. If it's not numeric, it just returns false, and you'll end up with 0. Now this one here is interesting to look at. This is where the data is actually formatted according to the mode that it is in. The device does not actually output like the word overload or open, that like it displays on the screen. It actually outputs a number that is exactly like that, 9.9000E plus 37, and that is actually telling us that there is an overload condition, or in the case of continuity in diode, it will be open. So we respond to that, and depending on the mode we output the right string for that to display. Then if it is not an overload condition, then we get the numeric value. Then we get the absolute value, because we don't want, we have to modify it, so we don't want to deal with having a negative value. Because that would make it hard to deal with when we do these comparisons over here. So we take an absolute value, with other words, it's always going to be positive. It's the same number but positive. If we're dealing with voltage or diode mode, we want to display the value in volts. That is done over here. If it's less than 1000, then multiply it by a million and say that it is microvolts. And if it's less than 1, we're going to display it as millivolts after we multiply it by 1000. If none of those are the case, it'll just take the raw value and it would be volts. Similarly, for resistance and continuity, it is ohms, but now we are dealing with a different kind of value. So now we're saying if it's larger than 999,999, one less than a million, in other words, just divide it by a million and display it as megohms. Otherwise, if it is greater than 999, divide it by 1000 and display it as kiloohms. If it is smaller than that, then it is ohms. It's just going to display it as ohms. Current is very similar to voltage, but now we're talking about amps, microamps and milliamps. Frequency is there's only 2 levels there. It can only handle up to 300 kilohertz, I believe, anyway. So if it's greater than 999, divide it by 1000 and display it as kilohertz. Otherwise, it's hertz. And don't need these breakpoints, so I can turn that off. Capacitance is a little different. Again, it comes back with farads instead of microfarads, so therefore we have to look, if it's less than 1000, then we're going to multiply it by a million, because otherwise, you know, because it is in farads, it's always going to be less than 1, the value. So it's going to be like for microfarads rather, is always going to be 0.00001 would be 1 microfarad, right? So therefore we have to multiply it by a million and to get microfarads, and then we can say, okay, then if it is less than 1000, then it's a picofarad and multiply by that, and so on. It's a little bit tricky to get your mind around, but that's how it works. We then make a format string. We then use a string format to format it, return true. If it wasn't a numeric value, because it failed this test over here, if it was a numeric value, it does this, but otherwise it does an else. Just return a text value, because for some reason it was a string of something which you will want to display, but it's not numeric. ToString, convenient way to look at it. We're not using it here. We used it before in part 1 in the console to display it. Never mind. And update I'm not currently using either. It's just a way to update the value in this query value, but we are using this update. This update actually passes in the measure mode as well, but this lower level update only has a value and potentially a precision if you want to specify that. So that's what Skippy query value is all about. And Skippy device is actually the next layer down from or next layer up, I should say, from Visas 32. So it is the only place where you will find the actual Skippy commands. They are only in this layer, and they are sent down to the lower layer, the Visas 32 layer, to be sent to the device. So this get measure description just gives you a displayable description of what measure mode DCV means, voltage DC, and so on and so on. Here we say set the device mode, and comes in as the measure mode, and potentially all the Skippy commands potentially come back with some sort of it stores the errors in that error list, but it will tell you the count as to for each individual step potentially how many errors there were, 0 if none. So If it is you wanted to set it to voltage, then this is the skippy command, conf volt DC, which is going to send it as a command. Similar for the other ones, voltage AC resistance, FRES, that means 4-wire resistance. I guess F stands for 4 or something like that. Frequency, capacitance, continuity, current, it's all there. And it does store internally when it connects to the device. There's a device address that it has and a device name, and it tracks whether it's ready. In other words, did it get initialized? It will be false if not, and then you can't actually talk to it. Resource manager is opened here. That's on the Visa side. Close, if we're closing down the software, then the session is closed and the resource manager is closed. This is a place where you can actually set an error. If you got an error to report, it'll just add it to the error list. And the actual device, when you want to get the actual mode, then you send a skippy command, sense func question mark. Any command that has a question mark at the end, by the way, on skippy means it's a query command, so it comes back with a value. So you would want to, that's why it says send and read, because it sends that command and then it expects to read something back. And what it reads back is, if it's in voltage mode, it returns a string called volt. If it's in AC voltage, it returns a string volt colon AC, and so on. But we don't want to deal with those strings. We want them to store them and know them as measure mode that we have defined over here. So we converted and output the actual measure mode. There is a status byte in the system, and we're only interested in this 1 bit over here, which is actually tells us if there are any errors to be read. And we actually output that as a boolean here, error bit is on, but we also output the command, the skippy command to read the status byte is this, star stb question mark, and we then return the byte as well, just in case you're calling this and you want to look at some of the other status bits. Maybe you have a need for them. We don't at this time in this software. So that is what that does. Now if that state error bit was on, bit number 2, then we need to read the error message, and then we issue a skippy command, syst error question mark, and it'll come back with 1 or more error messages. So that's why we stick them in a list over here, and we then return the number of errors that there were as from this call, so we know how many errors there were, and it actually ends up putting it in the error list. And errors is actually it adds as a range to the actual main errors list. These are low-level functions that are only used internally. That's why they're private. Write bytes, and write bytes as from a string to the actual device. And same here, we actually read a string from the device. Then we have an internal lower level send and read, sends that command and then tries to read and output that, and it returns it as a string from the device. So and at the end of it, it reads that status byte we're talking about, and if the status byte error bit was on here, you can see it being used, gets the error messages. And the actual string that it reads, we take out the quotes. We don't want quotes. It always puts quotes around everything, and we don't want any new line characters at the end, so we strip those out. Now here are some public methods that are used to read value from the device, from the multimeter. And it returns it. It expects a reference to a Skippy query value object, and that is where it is going to put the value that it reads in. And optionally you can specify a precision in case you, for some reason, you want to override the precision that this is going to be read back as. And here you see the Skippy divide for the read. It's read question mark. So it actually updates the query value. Then here is a send and read. That one here was only a read. This is a send and read, so it does a similar thing, but it actually sends a command first, and then it reads. It calls the lower level send and read, which actually returns a string, which then gets updated in the query value. And that query value, of course, is what you're giving it, so it'll be updated in there. If you only just want to send a command and you don't want to read anything back, for instance, those conf volt DC commands, for instance, they just set a different mode, and they don't, unless there's an error, but they don't come back with anything, and the error you pick up through those error messages. So it doesn't actually, we don't need to read anything, so we're only sending a command. And then the rest here is low level stuff. Open a resource manager, open session. That's done in here when you initialize the class. There is a public method here to find devices and find and open devices. This particular one here is what we're using at the high level, at the FRM, at the Hantek UI form, to actually get the it actually finds all the Skippy devices that are online. Like you might have multiple devices connected to your network, or you have multiple devices plugged in as USB devices or RS232 or whatever interface you're using. It will find them and it comes back with a list of them, and then you can actually go and say are any of them the ones that I'm looking for. So this is the identification. So for each one, IDN is a question mark, comes back with the identification, and reads that value. It's like the device name, and that is pretty much it. These two here we're not using, they just came with the example software from Hantek, and I put them in there just in case, but we're not using them. And I think that is all that there is, other than the actual code behind the form here. We are now at the highest level, and we're in a different namespace, Hantek UI. A few local variables and stuff. Region local variables, we can collapse that. Let's collapse them all so we can go to them bit by bit. Okay, so this was local variables. The actual measure mode management gets mode from a string. You can set the mode. You can actually set the mode from a button, and that is because the actual window has this toolbar here, and there are buttons there: DC voltage, AC voltage, DCI. So when they're clicked, we are just sending the whole button, because the button name is actually what the mode is. You'll see that later on. Timer has to be turned off because we don't want it to try to read values just while we're changing the mode. And so it gets, if there's no button, it just uses the default mode. But if a button was sent in, so whether it was the mode has to be changed, then it gets the mode from the button text, and then it actually goes on and actually puts the button. That's why it's also why the button is passed in. It puts the button in the toolstrip tag property, so that we know which button is actually currently active each time. You will see that being done a little bit later on. Oh, here, toolbar tag equals button. But right now we're saying, oh, if there is a button in that tag, then we want to disable it by, well, disable it, I mean low light it, so it's no longer highlighted. And then we are going to set the default mode to a new mode, save it, and then we're going to set the device mode. You've seen that code already. Give it the mode, and the error count comes out, but we're not actually using it here. I was using it at one stage, but not now. I could simply put a underlined out and underline here, then it throws it away. Now there is a problem with the Hantek firmware. If you change the mode, it takes it a little time to do it, a second or so. You can tell because you hear a relay clicking and it takes its time. If you try to do a read before it is ready, it becomes unresponsive, and you have to turn it off and back on again. So to overcome that, we actually wait 3 seconds so that there's enough time for it to settle down, and then we can carry on, display values and so on. So that is all we are doing with that measure mode thing. Some initialization, hide the toolbar, reset the display, initialize the display. We have a window movement because the actual window is normally displayed without a border. You can't move it, so we do that by putting this little label over here. It's called label handle, and if the cursor is moved over there and you click down on it and drag it, it'll move the window for you, which is what is done over here. We need to know what the last location was. As soon as the mouse is down, then we can actually track it. And so if the handle mouse is down, the handle mouse move, we actually defer that to the panel that all the controls are on. So then if there was a mouse move, we can now say, okay, or this is mouse down. If there's a mouse move rather, then this location minus where it was the last location and so on, then we can actually, and this location is actually the location of the actual form itself. So we can, it gets moved that way forcibly until the mouse is up. Okay, display setup and management. Report error. Pops up a message box with an error message. Resets display. Display values. This is called all the time. It gets the display values from the query value object, and it outputs a value and a unit. These get stuffed in text value and text units on the actual screen, the display screen, and the mode is coming from measure description where it actually builds the you know, like DC voltage and stuff like that. Message initialize display. Here is when we are actually calling that the find and open device, and we're giving it a device name, which is actually Hantek. And this is where it is initializing the actual values from the settings. They're all the settings here, so that it configures itself the way it was. Update the display. This is no longer used. The mode, in fact, I should probably just delete it. It might what am I doing here? There we go. It'll be confusing to people. I kind of left it in there in case to remind me why I took it out, but it's not necessary to have it there. The update timer. Now, because Skippy devices, they don't push data, you have to pull it. And when the device is running without being remotely connected, it triggers itself, and you see that on the screen. It'll say trigger, 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 and it displays values a number of times each second or something like that. I think there's some settings for that. It's PLC power lines cycles. You can set it to 1 or 10 or 100 or whatever. We do something similar here with the delay. So we have an update timer that gets triggered 4 times a second, 3 times a second, once a second, whatever you set it to, 10 times a second. And we need to manage that timer, so we got a pause function to stop it temporarily, a resume function to start it again. We have a proper stop and start that also displays a little picture on the screen so that we know that it is running and so on. And if the picture running and picture not running is clicked, it will either stop or start. If the start menu item is used, it actually has some additional code there. It'll say, hey, if it's not running, it'll try to open the device if it's not ready, and it's a way to recover from an error if you accidentally ran the software before you turned the multimeter on. You can recover it that way. Update timer tick is when it the interval is reached, it updates the display. So that's what that's all about. And we're dealing with menu commands, menu click, and also there is the set window color in there, and it is responsible for, if it's transparent, then it simply sets the transparency key and the back color to the same value. And I selected a value for no color right at the top, which is a murky, ugly brown, which I don't think anyone would ever want to use. So I am using that for the and I called it no color, and it saves it, and that is all that is there for the menu. Error management is simply the there's a little icon on the screen there, not that one over here, this one over here, which is only displayed if there are errors, and that is what this is dealing with, because you clicked on it, it was shown, then it's going to show a message box with a list of errors in it, and actually remove the errors from the list. Toolbar, that is the thing that has those buttons on there to change modes. some supporting information for that. In settings, this is a little bit interesting here. It actually calls that there's a menu item called settings. When that's clicked here, turns the timer off if it was running. It then creates this form, this one over here. New FRM settings, then it shows it as a dialog, and if the result that it comes back with is that you clicked on the actual OK button, not the cancel button. If you click the cancel button, then this code is bypassed. So see, if it's dialog result OK, only then does it do this. And if you look at the settings code, it actually only stores values in these. This is FRM settings. These are properties on that form. It will only set those if you have clicked on them and changed them. Otherwise, they are null, so they can be ignored. So that's why it says if it is not null, then do this. If the text color was changed, then it stores it in settings and changes the full color of the text that to the actual color that was selected. Same with window color and mode and unit and all sorts of stuff. It'll like this, the precision was changed here. It needs a new format mask and it does that. So that's what that's all about, dealing with the results of that settings screen. And as far as settings is concerned, this is the code behind it there. These are the values I'm talking about here. See, they're all nullable. They're not set, so they default to null. And they are set, the actual controls on the form are set to the values of the settings file. And then it actually goes and this is shows a little dialog just to select the color. And then if you click on those controls like the button text color, then it's actually allows you to select the color, which is then stored in text color, and that is actually displayed as a color. And that's pretty much it. So that's kind of it for a quick code review. As I said, if there's any questions, just leave them in the comments and I will answer them. And so that's it. I will leave it at that, and I'll see you guys later. And I hope that you have already subscribed, and if not, maybe you can do that for me and click the like and the bell and whatever there is there. So I'll see you guys later. Bye bye.